Today we're going to be solving radical inequalities. So let's think about these two words. Radical means it's going to have a radical sign in it, and inequality means it's going to have an inequality sign, greater than, less than, those kinds of things. The variable will be inside of the radical. So what we want to do is try to figure out what these numbers could be inside this square root to make this inequality true. You could try something like I'm thinking right now, 100 for example. 100 looks like it would probably work. Square root of 100 is 10. 10 times 3 is 30. 30 minus, nope, sorry, it's too big. It needs to be smaller, right? Let's try 1. Square root of 1 is 1. 3 times 1 is 3. 3 minus 1 is 2. That is less than or equal to 11. Great. So, but we want to figure out all numbers that work for x. So how are we going to do that? Step 1 is to set the inside of each radical. So there might be more than one radical in the equation. We're going to set it equal to 0 and solve for x. Again, just like when we did solving rational inequalities, that doesn't give you the solution. It just gives you possible test values. So in our inequality for this example, it's just square root of x, right? So we're just going to set x equal to 0. If there was something else in the radical, like x minus 2, you would set it equal to 0. So there's x equals 0. That's the number we're going to eventually put on the number line. Step 2 is to change the inequality to just a straight up equation and solve the equation. Again, that doesn't give you the solution for x, it just gives you test values. So we're going to change this to just an equation and solve, get x by itself. So what we do is we'll add 1 to both sides. We get 3 times the square root of x equals 12. Divide both sides by 3, square root of x equals 4. And then square both sides, not square root. Squaring cancels out the square root. So we get x equals 16. So we've got two possible, two values to put on the number line right now, 0 and 16. So step 3, you're going to place those variable values on the number line that you got. I'm going to put 0 on there, I'm going to put 16. Now why do I make them solid points and not wholes? Let's talk about that. Well, x can be 0, right? You can take the square root of 0. That's fine, you just can't divide by 0. And also, when we solve this equation, this is less than or equal to. So when we solve this equation, it will include that value. So we're going to put a solid point on that as well. Step 4, choose test values for each interval on the number line. So what do we have here? Well, we're going to pick a number to the left of 0. How about -1? That'll work. Pick a number between 0 and 16. How about 1? And any number to the right of 16 will work. I'm going to pick 25 because it's a perfect square, and I can take the square root of that easily. 17 is not going to work too well. Step 5 is to plug those test values into the original inequality. The original inequality was 3 times the square root of x minus 1 equals 11. So for my first test value, I'm going to plug in -1 in place of x. I'm going to plug in 1 in place of x and 25 in place of x. Let's check each one. Well, right here when we plug in -1, it's not going to work because we can't take the square root of a negative number. So therefore we know that this part of the number line is not going to be shaded. When we plug in 1, we get 3 times 1, which is 3, minus 1, which is 2. And yes, 2 is less than or equal to 11. So that test value will work, which means for this interval right here, where 1 was my test value, I will shade that. And finally, when we plug in 25, we're going to get square root of 25, which is 5. 3 times 5 is 15. 15 minus 1 is 14. 14 is not less than or equal to 11. So for this particular interval where I plugged in 25, I will not be shading that. So I will shade that portion in between because 1 worked in between 0 and 16. I don't have to test the other ones because 0 and 16, they're kind of like a critical number we talk about in calculus. The only numbers where the values could change, meaning where the values might not work and where they might work. They're kind of like, they're not the test values themselves, but they're place markers basically on the number line where we can test. So any of these other numbers will work as well. So you'll shade the sections of the number line based on which test values worked, and then step 8, write out the solution. So what does this mean? X could be anything bigger than 0 or less than 16, and it could also include those numbers because they're solid points, because we had this symbol at the beginning. So we have to include them in our answer. So it's going to be 0 is less than or equal to x is less than or equal to 16. That's going to be the solution to our equation. That's it for this example. If you have any other questions about it, let me know.